I'm sorry, Dave. I'm afraid I can't do that.
Before we start going through actually verifying trig identities, you should be familiar with the fundamental trig identities. These are the ones that we'll be using in verifying these more complicated ones. They can be found on page 536 of your textbook. You do need to be familiar with all of the reciprocal, quotient, Pythagorean, cofunction, and even odd identities for trig functions. Most of these you should already know. If you're still having trouble remembering them, you can come see me for extra help. I'll give you some tips on helping to memorize them. But for now, I would recommend taking out your textbook and turning to page 536 so that as we go through these examples, you can see which identities I refer to by name. So verifying identities. Now, whenever I'm verifying an identity, the first thing I'm going to do is take this equation and I'm going to draw a line down the very center of it, and I'm not going to pass this equation. So I'm going to be manipulating this expression and manipulating this expression until I get them to be equivalent on both sides. Now that verifies that whatever this is equal to, if they get to be the same thing on either side, then they are actually equivalent to each other. So let's go through this and see if in fact these are equal. Now notice the first one, I can actually use a cofunction identity and replace that entire numerator with sine of x using the cofunction identity for cosine. So this is sine of x over sine of negative x. Now sine of negative x has an even odd identity. Since sine is an odd function, this is really sine of x over negative sine of x. Since these share a common factor, they'll cancel out, and this whole thing is 1 over negative 1, which is just negative 1. So now, if these two are equivalent, then this right-hand side should also be equal to negative 1. So I'm going to see if I can use some identities to make this negative 1. Well, recall that cotangent has a reciprocal identity. It's actually 1 over tangent. So this is negative tan of x times 1 over tan of x. Well, again, tan of x and tan of x will cancel out and leaves me with negative 1 times 1, which is just negative 1. Well, since negative 1 is equal to negative 1, we have verified that this left-hand side reduces to the exact same thing this right-hand side reduces, and these are, in fact, equal to each other. So that's the basic process for solving any identity. Now I'm going to go through a couple of them rather quickly just so you can see examples and tips of what you would want to do. So here's another practice example. If you'd like to try it on your own first and then we can go through the solution together, I recommend pausing the video and going through this example on your own. I'm going to go ahead and go through it. The first thing I'm going to do is get rid of my fraction here on the left-hand side because that's kind of freaking me out. I'm going to do that by thinking of this as 1 over secant of x times 1 over tan of x. Well, these both have reciprocal identities. Secant is the reciprocal of cosine, so this is cosine of x, and 1 over tan of x is the reciprocal of cotan of x. So now I've rewritten this left-hand side without any fractions, and I'm already feeling better. Now cosine of x also has a quotient identity, so I'm going to see if I rewrite it with its quotient identity, if I can get some simplifications. So I rewrite my cosine, and then cotangent is cosine of x over sine of x. So it looks like this entire left-hand side actually reduces to cosine squared x divided by sine x. And I'm getting that by multiplying these two things together. You can think of this as cosine over 1. You multiply numerators, multiply denominators, and this is what I got. So I'm going to stop here only because I can't really do a whole lot with this. And I'm going to see if I can get now this right-hand side to look like this. Well, cosecant and sine are two different functions. So I'm going to see, I recall that cosecant is actually 1 over sine of x. And sine of x I can't really do a whole lot with. So now I have two different expressions. Now whenever you have two different expressions and one's a fraction, one thing you can do is find an LCD and combine into a single term. Notice that I only have a single term on my left-hand side, so if I combine these to be a single term, I should be able to get it to look like this. So to do that, I'm going to multiply sine by sine x over sine x. Okay, so that I can get it over the common denominator of sine x, and I'll end up with 1 minus sine squared x over sine of x. Now recall the Pythagorean identities. One of them, so I'm going to write this off to the side, this is one of the Pythagorean identities in that textbook on page 536, is sine squared x plus cosine squared x is equal to 1. Well, if I manipulate this by subtracting sine squared x from both sides, I end up with cosine squared x is actually equal to 1 minus sine squared x, because those will cancel out on this side, and I have 1 minus sine x on this side. Well, in order to get these things to look the same, I actually have to get this numerator to look like cosine squared x, and it turns out that it is actually equal to it. So I can replace this entire numerator using that Pythagorean identity by cosine squared x over sine x. So now my left and right hand signs are equal. I have verified this identity. So that's a couple things you can use. You can use variations on those Pythagorean identities, and sometimes if you have two different terms, combining them with an LCD is a tip for helping you reduce. Now, I will point out you could have used the Pythagorean identity on the left-hand side and replaced this by 1 minus sine squared x and then reduced, and you would have ended up with this. But as long as your trig identity reduces to the same value on either side, you have completed your process. Now, one other tip that you can use in reducing trig identities is factoring. So I'm looking, and I notice that on my left-hand side I have all sines, and on my right-hand side I have all cosines. So I'm going to have to convert sines to cosines on one of these two sides. So I'm definitely going to be using this Pythagorean identity, sine squared x plus cosine squared x equals 1 in some way. So I'm going to see if I can somehow use that over here. Well, notice that I have a common factor of sine squared x, so I'm going to factor that out. So you can use factoring strategically to kind of make life work a little bit better. So this will be 1 minus sine squared x left in here. Now recall from the previous example that 1 minus sine squared x is really just cosine squared x. So this is really sine squared x times cosine squared x. Okay? Now, if we do the similar thing on the right-hand side, I'll get cosine squared x times 1 minus cosine squared x. And 1 minus cosine squared x is just sine x. So this is cosine squared x times sine x using Pythagorean identity, sine squared x. And these are the exact same things. It doesn't matter what order you multiply in, those are equivalent. So factoring is another tip that can sometimes help you, particularly if you have fractions and you want to reduce those fractions. You might be able to factor the numerator to get things to reduce.
Sorry, didn't mean to frighten you. You're a bit late for that!